In order to solve this using substitution, the first step is to choose which letter you want to isolate by itself and which equation do you want to use for the isolation. Looking at this, the easiest equation to use is probably equation 1. You're free to isolate G by itself or J, it doesn't matter, but one might be more beneficial in the end. So let me just show you here, if we started off, let's isolate letter capital G using equation 1. What's that going to look like? What we're going to do is we're going to, first of all, move J onto the other side through subtraction. So E1 would look like G is equal to 40 minus J. These are usually worth putting a star or an asterisk next to because this is an equation that directly links J's and G's together. If you happen to know the number for J, you can plug it in here, and that would give you the number for G. That's why we like these. Now, we're going to use this, and we are going to substitute this relation into equation 2. So, if we rewrite equation 2, we would get G plus 16 is equal to 3/5 J. The substitution step will happen here. What are we going to do? Well, we want to rewrite this G and replace it with what we know G is. What is G? G really is 40 minus J. When we do that, though, make sure to put a set of parentheses in place of the G. What does that look like? What we should do is be extra cautious and put parentheses here. Everything else will be the same. Plus 16 is equal to 3/5 J. And where that G once was, this G now becomes this set of parentheses, and it gets replaced with the sets of parentheses and the relation 40 minus J is going to go inside. This is the substitution step. So you're substituting in the starred relationship for the letter G. Now when you start to work this, you're going to isolate J to get James's toy car number by itself. Here's what this is going to look like as we start to work on it. One of the oddities is this is not the answer to the question. We worked through this and we did a lot of things, but if we scroll up real quick, the question asked, how many cars did Gabriel have at first? The answer we got was regarding James. So when we solved this, we found that James had originally 35 cars. How do we go back and get Gabriel? Well, that takes us back to our little equation that we starred. Why? Now that we know the number for James, we can plug it into this starred equation and do a resubstitution for that letter J in order to get G. So it's at this last stage here, what we want to do is resub this value, J is equal to 35, into the starred equation. The starred equation again was G is equal to 40 minus J As we replace the J with the value 35, this becomes very apparent. Gabriel must have started off initially with 5 toy cars. One comment on this. What would have happened if we had isolated the other letter when we started this whole problem? You remember, we said we used equation number 1 and isolated G. If we had started this the opposite way and isolated J first, all of our hard labor up top would have actually ended up getting G first. And we would have been done with the problem without any resubstitution necessary. So depending on what the problem asks for, sometimes you'll get the answer just right here. Sometimes you'll need both of the answers. I'm surprised they didn't ask us how many cars did James and Gabriel both start off with at first. If that had been the question, the answer would have been clearly, Gabriel had 5 cars at first, James had 35. In part 2, I'll show you a slightly twisted way of doing this using elimination to get started.